The question is asking us to solve the following equation: 4 upon x plus 2 minus 1 upon x plus 3, which is equal to 4 upon 2x plus 1. Now, this directly doesn't look like a quadratic equation. So what we need to do is actually simplify it a little by taking the LCM at all of these junctures here, and then hopefully it reduces to a quadratic equation, which you can solve by the factorization method. So let's simplify it into a quadratic equation. So we have 4 upon x plus 2 minus 1 upon x plus 3, and this is equal to 4 upon 2x plus 1. This here is our given equation, right? Now, if I am to simplify this, the first step to simplification here would be actually taking the LCM on the left hand side. So that would be cross multiplying here basically. So 4 into x plus 3 is what would be here, x plus 3, and then minus, don't forget that, so it's a minus 1 into x plus 2, right? And the entire left hand side will be with the denominator. So when you take the LCM, as you guys know, you cross multiply and you multiply the two denominators. So I have x plus 2 into x plus 3. This would be my left hand side, is equal to 4 divided by 2x plus 1, right? Let's further simplify the left hand side. We'll have to use the distributive property here. 4 will get multiplied to these two terms, so I get 4x plus 12, and minus 1 will get multiplied to these two terms here. So this becomes minus x and minus 2, right? Further on in the denominator, again we'll have to use a distributive property as well. So x into x and x into plus 3, right? So x into x will make it x square, sorry, and x into plus 3 will make it plus 3x. Same way, now 2 into x and 2 into 3, so 2 into x will make it plus 2x. We have plus 2x, and 2 into 3 will make it plus 6, right? So divide by 4 upon 2x plus 1, right? We still can simplify this a little more. The left hand side, so we have 4x minus x will make it 3x, plus 12 minus 2 makes it plus 10, right? That numerator divided by, in the denominator we have x square, plus 3x plus 2x is plus 5x, and plus 6 is equal to 4 upon 2x plus 1, right? Now let's cross multiply again so that we have all the terms in the numerator. So that will give me, okay, so some more space, that will give me 3x plus 10 into 2x plus 1 in the left hand side, which is equal to 4 into x square plus 5x plus 6 in the right hand side, right? Once again, we want to expand these two brackets, so we'll have to use a distributive property. So 3x into 2x and 3x into plus 1. So 3x into 2x is 6x square. 3x into plus 1 is plus 3x. 10 into 2x and 10 into 1. So 10 into 2x is plus 20x, and plus 10 into 1 is plus 20. 4, again distributive again, 4 into all of these, so 4x square plus 4 into 5 is 20x, plus 4 into 6 is 24. Okay, so let's rearrange these terms so that we have all the terms on one side and equal to 0. That's like our quadratic equation. So we have 6x square here, we take the 4x square here, so 6x square minus 4x square will give me 2x square. We have 3x plus 2x, which is 23x, and plus 20 becomes minus 20, so that will give me plus 3x, right? I have a plus 20, oh sorry, it should be a plus 10 over here. 10 into 1 is 10. I don't know why I told it as 20. Anyways, sorry, this should be here. So if I have a plus 10 here and a plus 24, bring that on this side, so it's minus. 10 minus 24 is minus 14, and this is equal to 0. So I finally have my quadratic equation that I can solve by splitting the middle term by factorization rather. So if we had to look at it again now, remember, first thing is to make sure it is arranged in the standard form, which we did do over here. The second step would be to multiply the coefficient of x square and the constant term. So the coefficient of x square here is 2 and the constant term is minus 14. So 2 into minus 14, the product that we get is minus 28. Okay, so what we want is two numbers which multiplied gives me minus 28, and when they are added they should give me plus 3. So two numbers multiplied minus 28 and added plus 3. It's basically 7 into minus 4, right? Because 7 into minus 4 is minus 28 and 7 plus minus 4 is plus 3, right? 7 into 4. So that is going to be how I'll split my middle term. So I have first, therefore, 2x square plus 3 can be written as plus 7x minus 4x. So and minus 14 is equal to 0. So 3x was split into plus 7x and minus 4x. Again, now we'll have to start factorizing them. So therefore, if in the first two terms, if you see, we have x which is common, and I will be left with 2x plus 7. In the third and the fourth term, if you notice, we have minus 2 which is common, minus 2, and in the bracket I'll be left, so minus 2 gone, I'll be left with 2x, minus 2 gone, I'll be left with plus 7. The product of these two terms is equal to, the product here is equal to 0. Therefore now 2x plus 7 again, so that is common, and we'll be left with x minus 2. All of this equal to 0. So product of two terms equal to 0. We can use our zero product rule. Therefore the first term, which is 2x plus 7, is equal to 0, or the second term, which is x minus 2, is equal to 0. So if I am to solve the first equation and rearrange the terms and solve the first equation, I get x is equal to, so plus 7 minus 7 and upon 2, minus 7 upon 2, which can be written as 3 minus 3 1 upon 2, or minus 3.5, right? Or I can say x is equal to minus 2 on the other side is plus 2, so x is equal to 2. So these are my two answers. X is equal to 3.5 minus 3.5, sorry, or x is equal to 2. So these is my final answer. So sometimes we get an equation which isn't exactly a quadratic equation to start off with, right? As you can see in this question, it isn't a quadratic equation to start off with, which we needed to simplify a lot, and then eventually it ends up becoming a quadratic equation which we can solve by splitting the middle term.